Hey guys! Oh, am I in focus? I'm not in focus, am I? I'm now. Okay, good. Hey! Oh, I'm a bit hot. There we go. So, welcome to another live stream. How's everyone doing? Turn down the music a little bit. I like listening to the music. But then again, I have my own volume control, so don't have to bother you guys with it. Hello, Quindor. Oh, it's Johnny Bergdahl and Andilage is here. Andilge, I guess. And Timothy Mason is looking forward to this live stream. Nice. Michael Knowles is here. Good evening. Hope you're good too. I'm doing good. I'm doing okay. I was a bit sick earlier this week because I had a flu shot and things like that, but I think that's mostly cleared up now. I'm not enjoying the cold weather though. Doesn't jive well with me, but you know, that's how it goes. You are anticipating on getting Frunk later, hitting the bars. It seems like you're hitting the bars each week, Johnny. It's like you can only tolerate so much live stream and then have to go to the bar to drink it away. Oh, Philip is here. And Andy Mock, okay, and Eric Chabot. It's Friday, yes. It's Friday, so I'm here. That's not how it works, but still. Computer said no. What? Don't let her be the boss of you. Namaste, says Arun Ankham. I was not in the bar last stream. Okay. Good to be back to see a live show. Been having some health issues. Oh, that's okay. Hope you get better. Nothing to do with the goof. Okay. With the COVID, you mean? Hello, it's Fred here. Fred is het. Yes. What are you burning today? Well, nothing really, I hope. It's a prototype, so I don't actually know if it works. But we're going to find out. Hope it boots all right now. Are you on your phone right now, Emil? I'm confused. Hey, John Kuster. Hi there. So, we're still in the pre-stream, so I'm going to regular Coke. So, since we're still in the pre-stream, I hope I have fixed my streaming issues. And I was peering at my firewall for like an hour or so, and I noticed sometimes, like we noticed in the live stream, very randomly there would be a spike that would fill up my complete internet uplink, which is 40 Mbit or megabit or whatever. And then it would be gone again. And I traced it to a certain port, and that certain port is used by Chia. And although my server had been turned off for a little while, so the storage server, the VM that's running the node to keep the network in sync and things like that is still running, and it also has a little bit of storage. And that was doing network syncs and seemingly sending the information from my node, which is up like always, to others, which might not be up always, was very bursty since a certain update, I think. Because before I never had an issue. I've been running this Chia stuff for like 1.5 years now. But now it's become very bursty where it'll just spam your whole uplink and then be gone again. So I run MikroTik firewalls, and I made a queue which specifically captures that port in and outgoing. And it's now limited to 10 megabits. And, I'm hopeful that will resolve the issue. Because now the spikes are still there. It just can't go higher than 10 megabits. And since I have a 40 megabit uplink and I'm streaming at 16 megabits, should kind of work out. So, yeah. What? You want HA video? I've been dragging my feet on that one. Yeah. Maybe this year. I don't know yet. Oh, Michael Knowles got 2 weeks off after second day, 10 dig Uno and dig quads to build. Can't wait. Nice. Are you building the V3 DIYs? Will there be pink LEDs? Actually, no. They'll mostly be white or warm white LEDs. Maybe the background turns slightly pinkish. It randomly changes colors, so yeah. I might do a single HA video. I thought about making it a series at first, but I just never really got into it. I've been running it all this time, but I've never got into making it. I do have some upgrades I need to do there, but yeah. Yeah, I bought it too, Yako. I still haven't actually deployed it yet, so I really should get it off my feet and start doing something with it. But yeah. How things go. See, Brent is looking forward to the DIY solar storage battery project. Well, that is certainly coming. I dropped 10,000 euros on not on AliExpress, on Alibaba this week to get batteries, and they'll be sent out next week. And there's something else they're still working on for me. It's a custom thingy, and that will be sent out soon. So yeah, that is definitely happening, because I just paid like a whole lot of money to get some battery cells. So I guess I'll have to get on that. Yeah, but I bought 70 280 amp hour LiFePo 4 cells, and while those cost like 111 112 a piece, and then there's shipping, and how many dig boards are that? I don't know. Did you miss it? No, we just started. Yeah, 10K. Yeah, it was expensive. For sure. What is my bitrate doing? So my upload bitrate is set to CBR, which stands for constant bitrate, right? But it's jumping up and down. But we still haven't had any dropped frames, but I don't like it jumping like that. Shouldn't do that. But I guess, I don't know. Yeah, but we're not doing battery stuff today. That'll come like closer to the new year. And in the meantime, we'll do other stuff. AI bitrate. It must be. But, I mean, I don't mind AI bitrate if it had an AI bitrate setting. But if rate control is CBR, constant bitrate, it should, it should be constant. Oh, I do have Psycho visual tuning turned on, so maybe that will generate a few spikes. But I have it set to 16 Mbit, and I have a 40 Mbit connection, so, You are working on an 8 analog inputs and 8 PWM LED strip Raspberry Pi Pico-based controller board for work, says Amaury Jacquot. Okay. 10K is a lot of coke. Well, depends on which coke we're talking about. Have you done any solar/battery setups with the Dig Quad Uno? I'm about to try with my wife's greenhouse. Oh, no, I haven't. No. Not, well, there's the Dig to Go, which, if you're on the Discord, you can get. Hint, hint. Which, well, runs easily off of a USB power bank. Constantly floating bitrate, then. Yes, that looks more like it. Still, we haven't had any dropped frames, and I've only had one missed frame due to rendering and encoding lag, and our current rendering frame time is 5.4 milliseconds. That's fine. That's perfect. So, yeah, we'll see. But it's very spiky. And normally it's supposed to be like constant, but it's like spiking between 8 and 29. And I mean, I don't get why it's doing that, because it's not constant that way. Oh, OBS, what are you doing? Oh well. As long as we're not getting dropped frames and you guys are getting the nice 60 frames per second experience, we should be all good. Yes, dig to go. Yes, well, it's with a 2, but you know, with a the digit 2. There's some information up on the website, but it's currently a Discord only exclusive, and I guess now also a live stream exclusive. But yeah, if you go there to the announcement channels, you'll find the links where you can pick it up. Ah, Bpos doesn't seem to know my AllNet dig2go tracking number yet. Oh no. Where does the word name dig come from actually? Digital. Because what we're working on today is analog. So I have the AN quad and the AN penta and the AN... oh god, I don't even remember. Oh man. So I have a few DIY designs. So there is the original, the AN quad, the AN deca, and the AN penta, and those are all analog. And then I have the dig uno, dig quad, and dig octa, which are all digital, and dig2go. Your lights in the background, are each line run off a separate channel? Yes, in this case they are. There's a whole wire mess over here, and they're all running from their own channel. You don't have to do it that way, because it's only 288 LEDs in total. There's 4 strips of 72, so half a meter. But it worked out that way, so yeah. Quality is great. Stop watching the numbers. Thanks, Chris. Yeah, so the first people have started getting their dig octas in already, and dig2gos, because they shelled out for expedited shipping from AllNet, and then you'll literally have it in a few days. So yeah, that's excited, and the new stuff is now coming in boxes and it looks all posh, and oh, really excited for people to get started with it. I've been playing with it for a while, of course, but you know. So we're at time already. Let's sync this camera, and let's see if this works. There we go. So today we're talking about a prototype which I'm working on, and this is the Quinled AN-CC1. And basically what that stands for, this is a analog controller, but instead of constant voltage like all my other analog controllers, this one is constant current. And well, this one is basically suited to drive a single downlight like these you have in your ceiling. Those generally use like these little driver boxes or a single driver per board. But I kind of ran into a situation where it's like, okay, well, it's nice that I have all these lights, but I want to be able to dim them. And there's all kinds of solutions to do that over AC, and with triac dimmers and cutting off waveforms and all kinds of crap. I don't want that. I just want a driver that I can link to Home Assistant directly. And well, it turned out that didn't exist. So, hence my first prototype here. This is the AN-CC1 version 01. Today we're going to build version 02. Because although this one worked, it has an ESP32C3, and it has a USB, and it has multiple buck converters and inductors and all kinds of crap. Although it kind of worked, there were some issues with it that the basically the CC driver chip didn't upscale the incoming PWM dimming signal. So you'd actually see PWM coming through the cob LED, which should have been constant current. And if I gave it like 500,000 kilohertz or 750,000 kilohertz, yeah, then it will work. But I can't really generate that kind of PWM wave with an ESP32C3 here. So that, although it kind of worked, it didn't work. So what we're doing today is building version 02, which basically replaces this little chip here with, well, a different one, which now should still allow PWM from the ESP32 to come in to adjust the duty cycle of, well, the output current of this constant current chip. So let me try and explain constant current real quick. All analog controllers I have built and I've designed, we use for LED strip. They are made for constant voltage. So you take a power supply and that gives you 24 volt. And then the light draws whatever amps it needs at 24 volt, right? That is constant voltage because the voltage is always 24 volt and the strip will draw whatever. And if we PWM dim that, it'll draw less, but it'll still draw 24 volt. So yeah. Constant current changes that, where you don't have a 24 volt power supply, but now you have a 250 milliamp power supply. So the milliamps are set, and the volt is just anywhere between 12 and 60 volts. So this power supply can do anything between 12 and 60, and it'll do random whatever, but it can only deliver 250 milliamp. So now you connect an LED, and it'll try to draw the max current it can, because there's nothing limiting it. Except the power supply, which now says, no, hey, you can only draw 250 milliamp. So instead of now that the current is fluctuating, the voltage is now fluctuating. So it'll draw 250 milliamp at 37.3 volts. I don't know, something like that, for instance. And another light might draw 250 milliamp at 21 volts, you know. So now you determine per light how many milliamps it's supposed to draw, and then it'll figure out the voltage itself. And once these become warm and hot, the voltage will actually change. Maybe it starts out at 31 volts and it ends up at 32.7 volts. As long as it's drawing 250 milliamp, it's going to do that. It's fine. Whatever voltage it gets, as long as it's doing 250 milliamp. Now, for constant voltage, where we have our 24 volt power supply, we PWM the LED, and basically we turn it on and we turn it off real quickly, and our eyes average that out and see a constant light. Even all these lights you see here in my studio are being PWM'd, roughly at about 120 kilohertz. So my camera can't see the difference, I can't see the difference. Basically, if the light is on half of the time and off half of the time, we see 50% brightness. That's how our eyes work, that's how the camera works, you name it. So that's how normal dimming of analog LEDs with PWM works. But that doesn't work with constant current, because the voltage is floating and that would introduce all kinds of issues. So what they do is they basically get a giant inductor, which is this guy, which they PWM into, and an inductor kind of works like an energy storage. So it'll have a constant out, even though the input is going up and down, the output will be constant, as long as this is fast enough, and you know, there's all kinds of calculations to make there. And then you can say, okay, it can do max 250 milliamp, but if I want 50%, it'll just send out 125 milliamp. That makes it ideal for photo and video usage, because although you can PWM really fast like I'm doing here, if it's constant, there's no flickering, even if it would be at a low frequency, because there's no flickering at all, because it's just constant. That's hence the name. Power rectifier, yeah, sure, kind of. It kind of makes. So basically, you have AC and then you have DC also. Kind of does that. Instead of PWM, you could say is kind of AC-like because it pulses. And constant current is constant, so it's constant DC, except the voltage isn't regulated, the current is regulated. So I get that it'll be as difficult to wrap your head around. Most of the stuff you can buy are constant voltage LED dimmers, so they're suitable for LED strips and things like that. But these kind of lights really need constant current because they have cob LEDs and they just work differently. An LED, a constant voltage LED, generally has a resistor before it regulating the current. This doesn't have that, so you have to regulate the current. But then, you know, you can do it very specifically, and in theory, if you have long cables, it's also better to have constant current instead of having constant voltage with PWM, because that PWM is up and down, and if you make a really long cable, that means, you know, there's high voltage going up and down over that long cable, which basically means you've built a giant antenna with lots of power. So it's less advisable to do that. In practice, it generally works fine, but especially at lower PWM frequencies like 1K or 2K or 5K. But if you go above that, it could start interfering with other equipment, and then constant current is a much better idea because, well, nothing is bothered by constant current over a long cable. And even if you have power loss there, so voltage drop or whatever, over the cable, say you lose a volt because whatever, that light will still draw 250 milliamp, and even though your controller is 10 meters away, it'll just send a volt extra. I mean, yeah. Oh, okay. So let me read chat. So that's a quick introduction to constant voltage for most of the LED strips we run and things like that, and constant current. And this is my first test into constant current. And in theory it works, but in practice it's not practical, so it doesn't work. So yeah, this was version, well, it says it right here. This was version 01, release 1. And today we're going to work on... Uh-oh. No? Okay. Let me get it out of the package because I don't... See, I haven't even opened it up yet. I've had this for... I don't know how long. For a while. Because this is version 02 release 1. And it's basically the same thing, but now we're using a different chip. So we're just going to build one together. And the size has slightly changed because I want to use this with a certain case to see if it fits. Let me try and get this out. There we go. So this is, let's try and get them both in the shot. Now I'm zoomed in too much. Okay. So this is version 02 release 1. And, well, it does a few things differently, but that's mostly to do with this chip here, which is a completely different constant current chip, which I hope will upscale, whatever the PWM signal is getting in, so that I can send it 1000 hertz PWM, but it'll still PWM towards the inductor at like 500 or 1 megahertz or something like that. Because the faster you PWM, the easier it is to keep the inductor saturated, basically. And the reason the shape also changed slightly, the idea is that in the end it'll fit in a little case here. Oh, sorry, I missed the donation completely, did I? Andy Mock, thank you for the $5 Canadian. That's very much appreciated. For the LED fund, yes, thank you. Oh, a good question by Andilch. How would your controller handle LEDs that require different currents? For example, one light 200 milliamp and another 500 milliamp. Well, as you can see on the first prototype, there's 3 resistors here, and those basically determine the output of the constant current controller. This new controller can output up to 1 amp, but you can configure it using these resistors to, well, do a different value. And the idea is to maybe in the end make it with dip switches or jumpers or something like that. It depends a little bit on how much current runs through here. Or I might sell, if I ever sell this, I don't know, I'm just prototyping, different configured versions. So you can buy the 250 milliamp version or the 300 or the 400 or the 500 milliamp version. So yeah. So I have this case here, and the idea is that this PCB is exactly sized to go into this case. And it actually fits. Okay, I'm not used to designing stuff to go into cases, but this looks like it fits exactly right, doesn't it? Let me... Nope, hold on. I have to hold my hand here. So this type of case comes with these angled slots here. And the idea is that your PCB is the right size to go in between those slots, but not fall beneath it. There's a little bit of gap in there to have through-hole components, because those, you know, have something poking through the board. But this seems to fit perfectly. And then you can... you know, in the end, it'll snap together, or it'll screw together with the top case. And, well, this won't work because we need an external antenna, of course. But that's something to worry about later. Yeah, that seems to be fine. And these are all pluggable connectors. I don't know. We'll have to see. Interesting. I'm actually really happy that I got the spacing for these slots right. And I mean, I've had this thing lying around for 2 months. I got this before I went on my vacation to the USA. But yeah, so you basically make it so that it sits in this slot like that. And it seems to do that perfectly. There's a little bit of wiggle room, but that's okay. It certainly can't fall through, so that's fine. Cool. Excellent. Very nice. I like it. Okay, well that's for a later concern. I just wanted to know if that worked out. Might give it like another 0.1 millimeter or something like that, but that's it. Even bigger? There is already a pretty big offset there. Although on this version there's still copper. But basically nothing crosses this line or this line. But I should have pulled the copper back too. Because there doesn't need to be any copper there. That if the silkscreen layer, no, the solder mask layer gets scratched, you know, there shouldn't be any copper there. But other than that, it fits fine. Actually very happy with that. You know, you sit there tinkering late at night and you think, I think this is about right. I didn't have the case yet, and I didn't have these PCBs yet. So let's ship it off. Yep, send it. And sometimes it works out, sometimes it doesn't, you know. Yeah, sometimes stuff works and sometimes it doesn't, you know. Anyway, so yeah, that's the idea for today. We're going to build this guy. And there's some small components over here that's going to be really tedious. But the rest is pretty big. So, you know, the only way to do it is just to get started with it. I hope I'm able to find all the components. I have no idea, because as I said, I designed this months ago, and we're going to see. So let me pull up the design files. Where is it? No. Quinled CC1. Bomb. I-bomb. Do we have an I-bomb? Yes, we do. One moment, please. Let's see if I can get this on screen. display capture, no. This one. There we go. Oh, it's already ticked. I need to untick all this. I wish there was a way to do this automatically. So IBOM is something you can generate out of KiCad, and it basically generates a file which has all the parts and things like that, and you can easily use it to see where it needs to be placed and the orientation, and if you picked it up and have it in stock. And let me click here for a little minute. Oh, deleting browser cache clears it all. Okay, that's good to know. Well, I'm almost done now. So. There we go. Did I miss one? I must have. There's still... Oh, there we go. There we go. Okay. And now let me change the layout because that's not working. And then let's do this. And I guess you guys want to see the component value. Now where do I leave this guy? Over here? No. Over here maybe, and then I'll work over here. That could work. Okay, let me get my plank out. I need my soldering plank. Because the first thing we're going to do, and we're going to zoom out for that. There. Oh, damn it. Oh, it might actually still be in the right shape. So we need my soldering plank here. Because the first thing we're going to do is we're going to paste it. No, it's not in the right shape. Okay. So I have these tapes here. Which I need to pull off to adjust the size. Because this is mostly SMD parts, so we need to paste it. Okay, so this is fairly rigid. I'll zoom you guys in again. Nope, that's the other way. Well, I guess IBOM can leave for a little while still. So, there we go. So, let's get the paste. Paste and flux, yes. And then we need this guy and this guy. So I've got a scraper here, which is hardened metal, which really helps with getting the paste on there. And then a little spatula to, you know, get it out of the jar. And we need something else first. Oh, no, there might be addresses on there. We need our stencil. Is there anything incriminating on here? There is not. So let me get that out of its packaging. There we go. And if we then open this up, there. Come on. There we go. We have a metal laser cut stencil, which we need to get. And the trick is to try and line this up with what we have here. Yeah, that looks good. So you basically line it up in such a way that you don't see any solder mask anymore. Like so. So the solder mask is the green stuff over here. And you basically line it up so that when it's lying down like this, you can't see that anymore. Let's tape down the other side too. Oh no. Okay, well, it doesn't need to be perfect. Tape over there. Oh, I can't see chat anymore. That's a problem. One moment, please. How's the music on your side? Is it okay? Is it too loud? Is it too soft? Is it irritating anyway? Sorry, just fidgeting with my tape here. Okay. So I tried to get it slightly on tension so that I know it won't move if I push it. So here you can see, even if I push it, it's basically not going anywhere. That is what you want. Let me look at chat. I have no idea what's going on. Maybe everyone's gone. Oh, Johnny, you built a CC driver too? Well, but the other one worked. It just didn't, you know, and I could PWM it. Just, you'd see the PWM. That wasn't the idea. Okay. Okay, we have our jar of paste. I use this Chip Quick stuff. Refrigeration not required. Might be getting a little bit old though. Let's stir that a little bit. Oh yeah, this is less fluid than I remember it. Might have to add some flux, but let's keep stirring it a little bit. Okay, let's see if we can make this work. Otherwise, we'll add some flux later. Now, you basically take a little scoop like that. Innovation Fund, thank you. Thanks, Stephen Britton. Okay, so I just goop it on like that. So it's kind of spread a little bit. Oh, I dropped some over here. I can notice I haven't done this in months. I don't think I've actually soldered in months. That's bad, right? So let's get it all to the front. There we go. And the idea is... Wow, okay. Please forgive my inexperience here. I haven't done this in months. But the idea is you basically put it down here and you keep it at an angle. And while pressing down firmly, you go over the whole PCB like that. And, well, let's check how that worked. So we need to get these little tapes off, but try not to move it while you do so. And then we take a look. And as you can see now, all the pads and everything basically have paste applied to it. Nope, other way around. Even those little tiny pads over here and over here, and this one's lacking a little bit of paste. You can see a little bit of the metal still, but generally I'd say that is perfectly fine. So I take my PCB out and I put it to the side because we don't want to waste this paste. So we take our little spatula thingy again. We try and get as much as we can back in the jar. But yeah, this paste used to be a lot more fluid, I guess you could say. A higher viscosity, I think. Let's try and scrape it off of here too. Of course, it didn't work in the middle. There's nothing there now. Because you want to try and keep your stencil somewhat clean if you can. There we go. Okay, so I got the most off of here. And it's back in the jar, basically. Yeah, but I'm trying to save it, because now most is back in the jar. And so we just close up the jar again. Ready to be used another time. And I have a IPA right here. So let's clean the tools, because in theory I'm not going to need these anymore today. And generally with this paste, if you just go over it with a cloth, or, well, this is toilet paper, it works out pretty well. I mean, that's clean enough for me, that's fine. It's not like it's gonna do anything to the metal, but, you know. Downside of using toilet paper is you can get little fragments here in the stencil, basically, but as long as you clean it out before you use it, that's fine. The bottom, I don't think there's much on the bottom, but sure. Yeah, it's okay. So I always put the stencil back in its place, because if it's bent, it's basically useless. And that's why they send it in this, yeah, what is it? Cardboard, woodboard, fiber stuff. Okay. Let's clean up. I need to clean the knife, or the spatula. The downside of toilet paper is poo. It's also a good thing, because I'd rather have it on the toilet paper than on my hands. So, hey. Okay, let me put that away. There we go. So, we now take our non-flammable surface, which definitely does get burnt at some point. We take our PCB. There we go. I'll try and angle it over here and zoom you in a little bit more, because most of it is over there. There we go. So, didn't need the IPA today. Okay, let me get my tweezers. Now, I haven't really decided yet for this project if this is going to be pre-assembled only, pre-assembled and DIY, DIY only, never released. I have no idea. So I got my titanium tweezers here. They're very nice. I've been using these for a long time. I've actually bought more because I like them so much. They're very good. They haven't gone dull. Like, the tips are basically still as good as when I got them. They're a bit discolored, but they're nice. They're like $7 or $8 on AliExpress, but yeah. Right, so let's take a look at our I-bomb. Because the next thing is we need to start placing components. And, okay, I need a bigger window. Sorry. How am I going to do this? Okay, I could put it on here. But now you can't really see which component is what. Can you still read what component? No, you can't. Okay. Can we remove this toolbar somehow? Oh wait, I can just do it like this. Yeah, no, it's fun to be able to see. Okay, let's do it like that. That way I can see which components I need and you guys can too. It's not really... No, I know, but some people who also design might find it interesting what we're actually doing. So, right, so now the first component we need is 0402 10 volt 0.1 UF. Okay, so I go into my stash and I need a capacitor. Okay, I need to clean some stuff up first because I need to be able to move my boxes around. Capacitor 0603 0402. That's the one I need. Because I have all these boxes and they have labels on there. So this is capacitor 0603 0402. Okay, and then I go into that box and they're arranged in size, and we need a 0.1, so a 100 NF, which is basically one of the small 22 PF, 30 PF, 10 NF, oh 10 NF, yep. Oh, yeah, okay, we need 100 NF. 100 NF 0402 16 volt. Right? So that'll do. We only need 10 volt, but a higher voltage capacitor is fine. And we need 3 of those. So I'm going to put them over here. Oh, these things are so tiny. I always forget. When I don't do this for a little while, I always forget. Andelich knows my pain. He's like, let's see who plays those tiny effers. Okay, where do they go? Right. Let's hope I have steady hands today. That's one you can't see there. And there needs to be one over here. And one over here. There we go. That is the first 3 capacitors placed. I have 2 more, but too bad for those. So we're going to say sourced and placed. I'm going to skip the big parts right now. I'm going to only work on the smaller ones. So this is a 1210. I consider that big too. Okay, here we go. 0603 33 NF. We saw that earlier. Oh no, wait. 0603? Really? Yeah, okay. Don't sneeze. Yeah, I know. 0603. Maybe that should have been 10 NF. Okay. Oh, I might not actually have that one. That should have been an 0402. I'm not sure why it's not an 0402, but well, it needs to be a small value. 10 NF is a bit... I have a 56 PF. Why don't I have that? Oh, wait, no, okay. So it might not be in my standard box, but I know... I had a box here with special components I was missing last time. This box. And there we go. A 50 volt 33 NF. Oh, I actually already labeled it even. With my own labels. Cool. Okay. Yeah, but I have the right one here. So this is 50 volt 33 NF. That's perfect. And 0603. Oh, who would have thought? It's a new tape though. Come on. There we go. Yeah, I actually have a microscope, a trinocular microscope and everything, but I don't really like using it for this kind of stuff. I find that my camera over here gives you guys a clearer image, and it's not in my way either. There we go. If I have to do really close-up pitch stuff, I sometimes get it out for myself. But normally, if I don't go below 0402, I can manage pretty well. Okay, let's see here. We need a 0603 2.2 UF. So, 1 UF. 0603 2.2. Does that work? Oh, that works. Let's see, okay. Does it say a voltage? Yeah, 10 volt, and I have a 16 volt here. And I need 1. Okay. Inventory. A new open source inventory Docker container makes it easy to know where you've placed components. Oh, okay. Yeah, I sometimes forget what I have in stock, so some of the stuff I have like double or triple. If I'm doing it right, I just check everything before I place an order for the extra components. And sometimes I don't. Oh, and damn it. This thing hasn't gone through consolidation yet, because now I have a 100 NF or 0.1 UF 0603. Normally you wouldn't do that, because if you're building this with a pick and place, now there's 2 ports that need to be loaded on that pick and place machine, and if it would have been 0402, it would have only been 1 port. So, but we have those 2, no problem. There we go. 0603 10 NF. 1 4.7 10 6.3 volt. No, we need 10 volt. Okay. 10 UF 10 volts. 0603. Good evening there, Danny. You guys can almost see better than I can. Let's see here. Okay. 1206. 6.3 100 UF. Okay. I need a different box for that. Let's go back to the 0402s. The one... Oh, we need 25 volt 100 NF. Jesus. See, at some point when, you know, I'm nearing the end of a project... No. 16 volt. Need 25 volts. Yeah. I do item consolidation, and then these 100 NFs, I now have 3 different versions of them which would be very expensive on a pick and place machine and is just annoying right now. I just replaced them all for 0402 50 volts, and then they can go in all those spots. But I clearly haven't done that yet. And oh, okay, yeah, it goes right here. Oh, 402 10U. Oh god, okay, man. So I need one later, okay, and I need 10 right now. 10 volt? Yeah. UF, yeah, okay. And then I need a 1 UF. You can use a controlled resistor or a selectable resistor there, Ronald. I need one of these. But the problem is, depending on the design, there might actually be like an amp, up to an amp of current flowing through there. And if you want a selectable resistor... Uh-oh. Yep, it's gone. If you want a selectable resistor that can handle up to an amp of current flowing through it, that could get expensive there. Okay. 2 more. Because it flew away and it was never seen again. Yes, okay. There we go. Whatever is here can go away. Now I have to place these back, because otherwise I never do. And then at some point your whole system doesn't work anymore. Uh, 4.7, 4.7, 10, 10, 10, 10. Okay. Let's see what we then need. Okay, so we're then these are resistors. So we're going to move up to 0805 capacitors. Capacitor 0805. And then we need a 100 NF. 0. No. What? It's 0 ohm. That's a resistor. Why is it in here? Okay, anyway. 100 NF, 100 volt. Yes. That's why it's so big. It's done with a MOSFET. Oh, okay. Sure, I'd have to look into that. I mean, in theory it's possible if it's controllable easily. Okay, that goes down there. There we go. Ooh. Let's go back, and we need a 1206. This is my 1206 box. So that's easy. And 1206 100 UF. Oh, okay. Yep, got that. No, you can't do this with hot air. Or, well, you can do it with hot air. Air, in theory, wouldn't advise it. But you definitely can't hand solder this. You'd go mad. You'd go mad. Okay, well this is easy. That's a big chunker. Okay. And 1210. 100 volt 10 UF. Do I have that in here? 1210 10 UF. Don't actually know. Maybe that's one of the extra order ones. No. No. Not yet. Okay. But I don't have a 1210 box. Uh-oh. 1206. 1206. This is also the time when you find out you don't have the part. You decided that it need to go on there yourself. Where would that be? 1210, 100 volt 10 UF. Interesting. Just trying to find it here. It doesn't seem to be in here. That's problematic. Where could that be? Did I maybe chuck it in the resistors? Could be. It's possible. I shouldn't do that, but it's possible. No, this is all resistors. Okay, I need that later, but... These solder from last version. I don't know if the last version had these. It could be in a random box that I have lying around here. Let me check that. Nope. Nope. I might just not have ordered it. That's very possible. What's in here? Nope. Something else. Well, we're skipping that one for now. Well, I was kind of afraid that that is what it would be. So far, we're doing pretty good. So let's skip this one. I also need a 1 UF. I think I did see that one. And it's in my 1206 box, which isn't correct. No, this is a 4.7. At 100 volts. So I have two 1210 capacitors. They're in my 1206 box, which isn't correct. But they're the best replacement I would have right now. I'm going to quickly browse the web to see if I ever ordered these, because they should be in one of my last orders. Let's see here. I know. I kind of knew this was going to happen, but you can leave the paste on there for a few hours. That's fine. Or well, it's fine enough. So let's see here. Did I order any? This is a resistor. Resistor. Okay. Did I order it here? $12.10, 4.7, 2.2. Resistor. 4.7, 2.2. I just never ordered it. Let me check this order real quick. Nope. Okay, checking one last order. Yeah, no, okay. We don't have those parts. Yeah. Well, that deserves a... So, okay. Oh, you could actually see my LCSC order there. Okay. Well, that's not too big of a problem, I guess. We're just gonna do what we do have. We need 100 volt parts. So, okay. We do have a 4.7 instead of a 10. So, we're going to use that. I guess we could stack 2 if we really wanted to. But we're just going to see what it does like this. So, 4.7. Generally, I go overkill on the capacitors anyway. And here we need let's take that off, okay. And here we need a 1, so we're going to be placing a 2.2. Because I just checked my recent orders. And, well, I don't have them. Hate to put them on my list. Man, this is always so irritating. Stacking components. Yeah, now we're talking, right? Well, actually the stacking would get us pretty close. With 4.7, so that's generally close enough. But with these capacitors, there's generally some leniency there. I tend to over-design things. But maybe we'll stack it later, you know. So let's tick that one that I placed it, but that I didn't have the right one. There we go. Okay. No, wait, this one. Okay. Yeah. Okay. I should put these back in the box. Well, it depends on what shipping you use there, Emil, but generally they should arrive pretty quickly. Let me read chat for a little bit. Oh, Simon actually said you can stack 2 4.7s. Yeah, we'll do that later if it's misbehaving completely somehow. We'll try that. As I generally over-design things, so it might be fine. Okay, we need 1210. Let's go with the smaller ones first. Resistors. Oh, wait, I have the 1210s here. Let's go with the 1210s. So, over here, it usually goes through Luxembourg. Over here we have the 3 resistor spots. That's these here, and we need to determine. Damn it. Right, I'm back. We need to determine a value that these resistors need to be. So I made a little document. Can I open that in here? Yes. Let me enhance. Hold on. So we're using an AL8862 as our constant current driver or buck converter, and I made a little list here. And if we want, let's say 250 milliamps, I think that's a good value to start with. Is that correct? We need 0.4. Yeah, that sounds correct. Okay, we need 0.4 ohm of resistance. Okay, now let's see if we have a 0.4 ohm. You just swallowed the resistor, yeah. Oh, we have 300 milliohm, so that would get us 330. 330. Oh, we have a 400 milliohm resistor. So that's 500 milliwatt and 400 milliohm. That could work, but as I said before, there might be a lot of current flowing through here, and that might overwhelm a single resistor. Now we're going to try it anyway. But the idea is that you can also combine multiple resistors to get to the same value, which then would share the load, basically. Yeah, that might be an issue there with the current, Emil. But let's get this one on here for now, and, you know, if it gets too hot, we'll see that, and then we can replace it for several resistors. And you'll be wanting to replace these at some point anyway, because I'm going to be doing testing, and so I'll be testing different values and things like that anyway. So yeah. So let's start with 1 for now, which should give us that 250 milliamps. So just putting it right there. Okay, let's go back to the BOM file. Okay, so now we placed all of these. Okay, we need 0402 and 0603 resistors. That's not this box. Unlabeled box, that's always good. Resistor 0402. That sounds like what I need. Yeah, it can be done using dip switches, but then you have to build a whole circuit to do that, because a dip switch won't take 1 amp of current going through it unless you buy like a €6 or $1 dip switch. So, let's go 0402, and we need a 10K. Okay. 10K 0402, yes. And we need 2 of those. And, oh, those go over there. Okay. sticking to the tweezer. Okay, got those. Okay, then we need an 0402 3.3K. Let's put the 10K back. Or for 3.3K, okay. 3.6, 3.6, 3.3. And we need 2 of those. Sorry if this part is a bit boring. Just some random guy on the internet placing parts. I like watching it myself when others do it though, but you know. Oh, we got a donation. Kevin Mossman says, "You are amazing," with a sticker. Thank you very much. You are amazing yourself. That is awesome. Thank you. 3.3. A diamond painting? Okay. What? We need more 3.3s, but then spelled differently. Sometimes I hate myself. Could nobody have said so? You appreciate all my videos. Thank you. That is very nice to hear. Thank you very much, Kevin. This one goes over there. Okay. Let's see, do we have any more 0402s? Yes, we do. We need a 220 ohm. $330, $249, $249, $100. What? Huh. That's interesting. Don't I have 220? 39. 39. Oh. So, I don't seem to have a 220 ohm. That's a problem, because this looks like a divider for one of the buck converters. I don't know why I made such a stupid mess of the parts. But we always have the sample book to the rescue. Yeah, because I have these sample books and they're full of cards with specific value resistors. Let's see if we have a 220 ohm in there. And we do. So that's why I always buy a lot of these books. Because, let's try and make you see. Oh, no. So there you can see all the values, and if I forget to order a certain value resistor or capacitor in 0402, 0603 or 0805, I have a book for each capacitors and resistors of those sizes, and well, then I can recover from such a snafu using one of those. So this is a 220 ohm. I'm not sure this is an 04 or 2, but I'm going to see if it fits. Yeah, that's an 0603, I think, but it'll fit in that spot, so I'm going to leave it there. And then we need a 56K. 130, oh, 56K, I do have that. This will be an ESP32C3. So it's basically the, yeah, I guess some call it the replacement for the 8266. But it's a cheap ESP32, which should do fine for the current application, basically. There we go. It's a bit tight in that spot, but I'm hoping that's going to work. Okay, we need to go to 0603. Where is my resistors? Oh. That's interesting. Oh, here it is. I was going to say, I'm missing my 0603 box, but it's right here. And then we need a 51K. Yep, I have it right here. 75 volts, that's correct. Go. And then we need a 30.9. Let's hope we have that. That's very specific, but we do. Let's see where that goes. Okay, that goes over there. So those are resistor dividers to determine the buck converter outputs. There we go. What have you been eyeing? For the ESP32C3, you mean? The code for them is still a bit new, so that's a bit tricky sometimes. But other than that, the previous testing version worked okay. We need an 0603 5.1K. Who can tell me what an 0603 5.1K is for? Two of them near the USB port. Who knows? Who knows? LED resistor, printer driver, data lines for USB 3. Emil Bart is closest. That's not quite it, but close. I need is 2 0 ohms. Okay. think these are zeros. Tell USB-C to go to 3 amps. USB PD activation. Yep, that's exactly it. So it's a form of USB PD, but not active negotiation, it's passive negotiation. And it basically tells the USB port, hey, I want 5 volt and give me up to 3 amps. And, you know, that's what they do. And that's a very easy way to do it. But still, enough products on the market right now somehow manage to not do it. It's 2 resistors. And it makes the difference between connecting using USB-C to a charger and that the USB-C charger will be like, oh, you want 5 volt 3 amps? My guy, let's do it. And if you don't have those resistors, the charger's like, I think I see something, but it doesn't tell me what it needs, so I'll just give it nothing. And it's so stupid. It's just 2 resistors, and a lot of products forget them. So dumb. Anyway, let's see here. Oh, we still need a 210 4.7. 2 of them, actually. We already placed 1 of them, but I need 2 of them. Huh. Well, we have those. So I need to get my 1210 box back. Those are the resistors for making it capable of smoking. Oh wait, this is resistors. Now I'm talking about resistors too much. I need capacitors. There we go. 2.2, 4.7. Magic smoke canisters. Well, we will be placing capacitors later, don't worry. The big ones. Well, these are kind of big ones for ceramic, but yeah. Okay. Let's see. It looks like from the graph, most of the things are orange now that we have most of the tiny parts. We still need 3 diodes. Let me put my little book back. Whoa. Oh, the hookup is here. You ever thought about making a USB-C connection LED driver board that you can toggle between 5 and 12 volt via software? I have. There might be something in the mail to you. But that's 5 volt only. A next version, I might do a... I'd probably make it hardware selectable. So either a jumper or a switch or something like that. Because if you make it selectable by software... if its software is set to 12 volt, but the LEDs that are attached to it are 5 volt, and you put it on to a 5 volt only supply, I think having it software switchable would make it difficult to use. So if I do it, I'd likely make it hardware switchable instead of software. And then there's also the point of, do we want 12 volt or 20 volt in, and then output selectable to 5 and 12 volt? Or do we then use 5 volt and 12 volt from the USB PD power supply? Or do we do buck conversion there? Yeah, there's multiple ways to do that. Where's my diode? I used to have a box with diodes. Maybe I don't anymore. Diodes. Okay, we need 3 K210s. Oh god, this is not in order, I think. Nope. 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 Just hold on a second. Nope. K210s. There we go. That's true. The other thing I was really hoping for lately was a built-in relay to be able to keep the main power supply on but cut the output of the strip. I get that. Again, there is something in the mail to you that works over USB-C that has that functionality. But for the larger controllers, I get that, but it makes less sense because then the idle wattage of the power supply itself, like a 20 or 30 amp power supply, is generally pretty high. But the dig to go, which is in the mail towards you, it has a MOSFET based circuit which cuts off the LEDs completely, so just the ESP32 still takes power, and then it goes down to like 0.4 watt standby or something like that. Even with 300 WS2812Bs or something like that connected. Right, these need to go in the right order. I'm gonna cheat and look at my previous design. Let me get my magnifying glass. Because I don't remember. I usually alter the drawings on the board. Oh god, they're on both ways on this board. That's not great. Okay. Hold on just a second. I need to make sure I put these diodes on correctly. Yeah, I'm pretty blessed with having good eyes and steady hands. Right, so stripe in theory goes into the box. Okay. Let's see here. Stripe goes into the box. There we go. And the third one, where does the third one go? Oh, there. Those are actually custom footprint, because I don't like the footprint KiCat uses. Okay, let's see what we then need. I don't think we need any other diodes, so we need an orange LED, and that's, of course, also has a polarity. LEDs, I think those are over here. SMD LEDs, 0603. Don't really care about the color, but it says orange and I have an orange one here, so. Here we go. Right, and it's over there. And let me check using the same method again what the polarity should be, because I always mess that up with stupid LEDs. So ground needs to be on the bottom, so Oh, where the little dot is? That's good. I put a dot there. See? Sometimes I think ahead. And in theory... But then again, it depends on the LED you have. So there's a little dot over here. If the stripe is ground or the little arrow is ground. So if you look at the LED on the back, you can see it's a little bit too... I guess I could manually enhance. There we go. It has a stripe and then it has a little nubbin, and either the nubbin is pointing towards ground or the nubbin is ground. I never remember right. I'm going to assume it's pointing towards ground. Do you guys know? And from what I remember, there's a little green piece over here, and I believe that needs to be on ground. Uh-oh. Oh no, I messed it all up. Okay. There we go, we saved it. So, I believe now the green port is on ground. Yep. I believe that's correct. We'll find out later. Oh wait, I can check on my other board, right? That's right. Okay, on my previous prototype, it's the same way around. So we're going to assume that's correct. Let's you know, take it off. Okay. Polarity stuff always gets me. Let's see. Now we have mostly bigger stuff left, I think. We did... No, we didn't do that one. Okay. Okay, let's go to the chips. The chips. We'll do the inductors last, because those are biggest. Let's do the AL8862, which is the driver. And if you can see on the I-bomb, it has one of the boxes lit up with yellow. That is pin 1. So there should be an identifier on the chip also for what is pin 1. I know I'm still zoomed in. Just one moment. No. Oh, I need to select the right view. I'll leave it like this for now, so you have a bigger view. Okay, so pin 1 is over here using the I-bomb. And let's look at the chip. Oh, okay, well that's easy. I'll just place it, because then you'll see. It has a very clear marking what is pin 1. Need to move it over a little bit. There we go. That should reflow just fine. Okay, that one is done. Right, we need 2 poly fuses. Let's take a look at that. PTC box. Oh, let me get that. Oh, it's far away. Okay. So, we need a 1206 with 500 milliamps. That should be fairly easy. Oh god, why is this such a mess? Okay, well, we'll need this later. Oh, we need this later. Oh, there's just too much in here. Okay. Let's see. 1206. 1206 100. No. 1812. No. 1206 500 milliamp. Yep, that's it. Now let's do the PTCs, because I know those are relatively flat, and I like working from the least high component to the highest component, basically. Okay, this one needs to go over here. Because that's to protect the USB port, that it can never draw more than 500 milliamps. That is perfectly fine. And then we need the... It says polyfuse small. That's not it. This is a... Go away. 1.1 amp, 60 volt. So that is for the input power. And since we have a 1 amp buck converter, we never need to be able to draw more than 1.1 amp. And if we do, something might be wrong. So that's why we put a PTC there. Okay. We're building a prototype board, the Savag. There we go. Right, those buttons are always finicky to place, so let's do that. Oh no. Okay, let's do something else first. Let's do the XL7015, because I have that box here. This is a long time to build a board. Yeah, this is not a short stream, because before the time that it's done, we're easily 2 to 3 hours in. So placing this one is pretty easy to identify how it should go on the board. There we go. Do I need something else from this box? Because this box has buck boost, LDO, and SMD LEDs. No, I don't think so. Inductors. Okay. Let's move on to connectors and buttons, because I need to dig that box out. Hold on just a second. Yeah, I'm looking for that IC next to the USB-C port, actually, because that's a ESD protection IC. But, oh, that might actually be in this box. We need this box later. So we have a big capacitor box. And then we have the USB 32 box. And then we have this one. And that should have that USB-C protection thingy. Let me check. No, not yet. There we go. That's this guy. No, all this music is from Approaching Nirvana. Okay, let's throw it back in there like it was. Let's see here. Where's pin 1? Do I have pin 1 marked? Yes, I do, because I have a nice... You just can't see it. I have a nice little dot there on the board. See that dot? There is a dot on this little chip too. So it goes on like this. There we go. Easy does it. So let's cross that off the list. We're getting there. So that's this guy. The pitch of the DC converter looks wrong. You mean it's skewed slightly, or that'll fix itself during reflow. Well, you'll see that in a minute. So I need push buttons, USB-C connector. Okay, let's do that. Now let's do big caps. I need big caps. Big caps. Yes. I need two. Music. I need two 100 volt 33 UF caps. I have 56 here. That's a good alternative. 100 UF. 33 UF 100 volt. Okay. On the XL750. No, that's just the paste there. I might be able to adjust it slightly like that, but that should reflow fine, I think. Hold on, these are big my pajamas. I could check the footprint for that later. But that's the same footprint I used on my previous board, and that worked fine, so. But we'll see how it reflows. Maybe it needs adjusting, who knows. Oh, I wonder what C20 is over here. We haven't placed that one yet. Okay. So, capacitores. Luckily these have a clear way they go on. Because they have the notched corners. So you can easily see how to place them. There we go. That should be fine. Let me try and zoom the window out again. Nope, that's the wrong one. Why does it do that? It's irritating. There we go. Oh, Sevog Barsomian. Thank you very much for the 11. Oh, for the $6 for 11.11. If you were not aware, currently it's the 11th of the 11th sale on AliExpress. And there's some really good discounts to be had, either on the total order amount, because you get spend and save. And it's like $3 per $30 you spend, or $6 per $30 you spend, depends on the period. And there's discount coupons. Now, on my Discord, in the Quinboxed and Get a Link channel, I've been posting updated codes. And I personally have ordered a lot of stuff, and I think I've easily gotten $200 to $250 discount using those methods. So, if you're looking for that, might be interesting. Right, now, I can't get around having to dig out those big boxes. So, let's do that now. Because I know the USB-C and the switches are in the same box. Let me start by putting some other boxes back. Because I need the space. I'm going to need this box. not going to need this box. This can go away. Just one second. Just one second. I do need my inductor box. Don't know where. Oh, I still need this box. Does it pass my inductors? Yeah, this can go. Right, and we still needed to look at what that capacitor was. So, oh. See, I didn't. I forgot to place that one. So we still need that box. Let's do that right now, because somehow we seem to have forgotten it. It's probably because we don't have the right one. So we don't have a 1 UF, but we'll place a 2.2. Yeah, that should be better than nothing. Seemingly I forgot to order these. Okay, there's one. And then this box will be back. Let's put it in its place real quick. There we go. Who knows? Maybe it'll work better than the part I thought that needed to go there. So the buttons and the various connector box is a lot bigger. Let's see, we need a USB-C. Oh, I think we need some of these. Let me check. Oh, we need some of these. Have I used this before? Yes. Hold on, I'll show you in a minute. That should be it for this box, I think. So, we have my USB-C plug over here. And that goes on like this, but we're going to do a little trick. We're going to take a syringe with paste. And I'm going to squirt some paste into the holes. Suddenly the music turns very mysterious. Because you can fill those holes up with solder later. That works too. But I like using this method where... And then we get some tissue paper to squirt out the first part. So I take a syringe with the same solder paste, and this has been in here for a while, so I need to get that out first, because it's been in the syringe. Okay, that should be fine. Let's see what comes out now. Yeah, okay. So then I go back to the PCB. And you have these 4 holes here, and I'm sorry if I'm going to block the camera, but I'm going to squirt a tiny amount on there, basically. It's always messy. My workspace isn't that big. Okay, I'm going to use my my tweezers to move it around a little bit. There we go. Because I basically want to have it cover the holes. And then I'm going to take my USB-C plug here. Put it in. Push it down. And then the legs, in theory, go in with that paste there. So that will immediately give it some rigidity once it's been on the hot plate. And then we can add more solder to it later. But it's a lot better than just having the normal, just the tiny little pads there. Okay, so let me clean this up. That's exactly what I'm doing there, Dutch maker. Clean everything up while you're working on it, because you don't want to do it later. You don't want to do it now, but you certainly don't want to do it later. So, okay. Yes, so let's do the USB. Let's tick off the USB-C plug here. USB-C. Now we do the buttons. I'm not sure I need that, but okay. I got the wrong buttons. Damn it. Okay, we'll do the buttons in a minute. We'll do the Stemma QT connector there, or the Groove Mini, or whatever it's called. Basically for I2C expansion. That should be pretty easy to put on. There we go. Okay, let me get the right buttons, because these are the wrong buttons. These are not the buttons you are looking for. I think these are. Not 100% sure, but we'll see. I guess we'll try one. Thanks for being here, Andy. Come on. Or did I use these last time? Oh, I used the other ones last time. Hold on. Hold on. Hold on. That's easier. Come on. I need 2 of these buttons. This can go back. This can go back. We're getting there, guys. I know it takes long. We've been at it for at least 2 hours now. But we're getting there. Almost ready to reflow. So these should fit very nicely on this footprint. And they're very nice buttons. So there we go. More to tick off the list. Push buttons, done. So power loop we don't need to do. This one we did. This one we don't need to do. That's the ESP32. We'll do that last. And then we need 2 inductors. And for the inductors I have the box here. Almost there. Almost there. So we need a 100 microhenry 1 amp and 2 amp. Now I know I ordered inductors here, and I think that's because I needed different ones than I had. Right, so this is a smaller 100 microhenry. I think that'll fit. Come on. It's in a bag that, you know, goes in another bag. Okay, so inductors aren't polarized, so that's easy. And this should just go, oh, let me check the bottom. Yeah, that should just go there. There we go. That's one inductor down. And this should be a bigger inductor. Yep. Now with this one I might want to experiment, so I don't know if I put the pads, or the pads are the exact size I need. But they should at least be big enough. Come on, get this stupid foil off. There we go. Yeah, these are chunkers. So I'm going 100 microhenry first, but we can always go bigger, like 220 or 330. Those I already had. I can't really use my tweezers here, so I'm just gonna put it on there like that. Huh. Seems I got the size pretty good. Oh, it'll smoke on the plate, that's for sure. So, one SMD component left, and that is the ESP32C3. So let's get that, and then let's get the hot plate out. Where are my ESP32C3s? So we have some with external antenna, and we have some with internal antenna. It's all external. Damn it. C3 Mini. I'm going to use an internal one. Although, if I'd ever want to put it in the case, of course I need an external one, but the footprint is the same. And I'd rather have the board easier to test right now without a antenna dangling off of it. But yeah, I have those two, so if I do decide to go forward with that, at some point I'll build a prototype which has that one on there to do more testing. Okay, so there it is. Now we need to get it on there without disturbing anything else. That is going to be an issue. Let's turn it around. Okay, I think that should do it. I can see the silkscreen line on each side. Yep. Do we see any parts that I forgot? What can I flip what over? The ESP32 module, I just had it. So you'll have to look in the stream a little bit back, because then you can see the back side of the module. It was on the stream, I believe. So, right. So let me make some space here. I don't need this. Well, I might need this. Okay, let's see if my suction works. No, it doesn't. Okay. Okay, we have suction. Yeah, R14 and 15 we are leaving intentionally blank because that selects the output current, and we needed a 400 milliohm resistor, which we currently have on there with a single resistor instead of a combination. But there's 3 pads there, so you can make multiple combinations to get the value you need. Okay. Okay. We have a modified hot plate here, which we did on previous live streams. But let's see if we blow the breaker again. I hope not, but we'll see. We'll see. Let's take this AC cable. I'm always so worried that in this stage I'll accidentally bump the board and, well, basically undo all of the work I just did. I have actually done that before, which really sucks. Or after reflowing, while taking it off the hot plate, I bump it. It's like the worst time, man. I've done that, like it reflowed perfectly. You take it off the plate, bam, everything's off the board. It's so bad, so bad. So I'm going to be extra cautious here and transfer to the hot plate. Oh, I almost tipped it over. Okay, I want to turn it around so I can reach the components better. Okay, now let me make sure you guys have a good view. There. That should show you pretty well, right? I could zoom it in even more, but I don't think that's really needed. Let's turn on the hot plate and see if the breaker blows, because this is the breaker blowing hot plate. Yeah, let's... So far we're still online. Let's turn this on. Okay, it's set to 180. That's good, because the paste is already a little bit older, but it's 138C paste. So 180 looks fine. Yeah, they said... The comment was there before that the pitch looked slightly off. We'll just see how it goes. It's currently at 28 degrees, and yeah, it's warming up. Oh, let me disable the... There we go. Yeah, that's true, Jaco. While this is going, we're at 41 degrees. Those new heating elements in there, together with the paste we did and things like that, once we got it working, this is a very good hot plate now. It's way better than it was originally, because we're already at 50C. I guess at some point I'm going to turn on the suction, but then this needs to be able to reach it. So, sorry for the noise. Yeah, that should have it. Yes, this is a mechanic hot plate, the ET10, but I used it so much that the internal heating elements basically gave out. And we did 1 or 2 live streams replacing those. In one of those we blew up my house breaker a few times, but yeah, we got it working in the end. And can I just celebrate We've been streaming for 2 hours and 13 minutes at the set 16 megabit rate, and we've had zero dropped frames in the network. So that seems to be working perfectly. Oh, we are already at 119 degrees. Let me actually turn it down a little bit, because it's set to 180. That's a bit much, so let's set it to 160. Okay. Oh, it's smoking. Yeah, you can see stuff happening. We're at 144. Yeah, we're almost at the set temperature. Okay, I heard the hot plate tick off, so we're around 160 degrees right now. I'm going to push this a few times over here. This should be okay. Yeah, that wants to go there. So let's check this resistor, because I used the wrong size. Okay, that seems to be working fine. This one is a bit wonky. Okay, this didn't work out over here. Okay, I pushed the ESP32 real quick and it flowed back into place, so that should be good too. This one is a bit wonky. Come on, what are you doing, man? That should be okay. This looks fine. That looks okay. Let me move it so you can see. Yeah, that looks fine. It's actually, I can see better on the monitor right now. This one has a lot of paste in it, but that's okay. Yep. Caps look fine. This one looks fine too. Yeah, it looks good to me. Any oh, the orange LED? Yeah, that looks good. Yeah, that's fine. Well, I can push it in its boundaries if you want me to, but you can actually see it light up when I touch it. See that? But yeah, that should be fine. I think everything's fine. I'm turning the hot plate off. The two caps at the ESP2, yeah, but those are now good, I think. Yeah, that looks good. Oh, let me push this connector a little bit. No. Oh, you can't see. Still crooked. It looks crooked on camera, but over here it looks fine, so I'm going to use it like this. Let me take my magnifying glass real quick. Yeah, that should be fine. Yep, that all looks fine. So, now comes the tricky part. I'm going to try and slide it onto my my cork here without bumping it too much. Okay, that worked. So I'm going to put the heat plate to the side. I can turn the cooling off. Now we have to wait a little bit for it to cool down. There's some solder balls, probably because the solder is getting a bit old. But once it cools down, we'll chip those off. And then I think we reflowed that perfectly. Need to check this capacitor real quick. I think it's still making contact, but let me see if I can still push it. No, I can't push it anymore. Yeah, that's still making contact. Sorry, I can't. I have to do this real quick with the magnifying glass, otherwise it's not going to work. Oh, you guys are actually right on the legs. Yeah, you're right on the legs for the XL715, this one. That footprint isn't great. What's this black sud here? Maybe this PCB got a little bit too hot, hey? Interesting. Either my paste is too old, or this got hotter than I think it got. Let me try and remove some of that. Yeah, it looks like paste, but it got up to 160 degrees, and I'd say most, or if everything melted, so... it's tough stuff. Oh, okay. Can't hurt, but, you know. Dirty paste. Yeah, maybe. I see a lot of solder balls, too, like this one here. Generally, you can, you know, get those away like that. There's one here I'd like to remove. There we go. Ow, it's still hot. There's one here. Is there actually something here? Yeah, there is. Oh, there's a big one over here. Come on. Okay, well, if it doesn't want to go, it doesn't want to go. That's fine. Why is there... This has been annoying me all this time. Why is there a little dot here? Was that something on the old design that was there that's not there anymore? I think it was. It was from a previous component that's not there anymore. Oh, damn. That's right, I didn't see that. Well, it shouldn't be a problem, because it's not electrically touching that capacitor over there. I didn't see it move, thanks. But yeah, electrically that should still work. But as I said, I'll be testing with this board anyway, so I'll be soldering and unsoldering and desoldering and resoldering that anyway, so yeah. No, the black is from the MOSFET? What MOSFET? You mean over here? Oh, MKME lab is here. Nice. But overall, I think it went pretty well. I should have caught this one, but electrically that should be fine, because as you can see, There's no way that's making contact. So, okay. Then we have to do our hand soldering. So let's get that out. Whoa. And I'm actually going to try new solder today. Now I don't know how long I'll stick with it, but I bought some new LED-less solder, or LED-free. Oh no, the camera died. So let me fix that first. Hold on. I still haven't unpacked that dummy battery. Oh. This should give us another 2 hours or so. Let's hope so. I have another battery, but I'd have to go get it. Okay, so yeah, we have new paste today. Or new paste. Well, I wish we had new paste. This old paste isn't that good anymore. It is connected to ground, but it's mostly there for fixation. Oh, well that sucks. Well, they put the label over it, but I want the original label. Hold on, let me see if I can get the original label here. Stupid Conrad people. Okay. There we go. So I have some Felder ISO core Ultra Clear. I have it in 0.75 and in 0.5 for the smaller volume. And I wanted to try that today because I haven't used it yet, but this is SN100 Ni+. And because I keep having issues with unleaded solder. Yeah, but that's exactly the reason there, Felix. I see some other people soldering with unleaded solder, and they're doing it like it's the easiest thing in the world. And then I'm like, my experience has been total shit. So we're going to try that, and we'll see. It's just these 3 connectors, and then maybe in the USB-C holes a little bit. So, yeah. Okay, let me get my terminals. Oh wait, let me get the other sides too. Good, I'll fix whatever fell down later. Oh, we got a question. Hey man, just caught your show. Just a quick question on the Octa. What size fuse should I use from the power supply to protect it, even though it has online fuses? If we're talking power boards or brain boards, you don't need to add extra fuses. There's input fuses on all of those. And you don't need to protect your power supply. You need to protect your wires. Your power supply should automatically cut off if there's an error condition. Right. Well, the wire looks nice. So, okay. Oh. What happened here? Huh. Not sure what that is. Maybe it was on the hot plate? Let me try if I can get it off. The expensive LED-less stuff. Yeah, this is not cheap, I guess. I don't know. Oh, it comes off. Maybe there was some residue that was left over on the hot plate or on this surface here. But it came off, so... yeah. Okay, let's place those terminals real quick. And of course the... damn it, the capacitors are higher than the terminals. So that's an issue. Finally, you're wiping its bottom. Okay, so the capacitors are higher than the terminals we're trying to place. That means we bring out the tape again. So let's quickly just, I don't know, stick this down. That should do good enough. I'll just solder one leg of each, and then we can always reflow it if we want to adjust the position. So we're set to well, 0 right now, but so let's get the suction in place, and I'm going to use my protective glasses. I should have done that before while reflowing, but you know. Okay, let's try and solder one leg of each, and let's try this little tip here. We're set to 350. Oh, you can see it glowing red. There's so much power in this thing. Oh wow, it overshot to 450. I might need to change some settings there. No, I have some blue tack, but I don't know where it is. Okay, let's see here. Okay, oh, that flows pretty easily. Let's wet the tip a little bit. Oh, okay. Okay, let's, I don't know, let's try one of the legs. Oh, well, that went fine. I'll try and get this better so you can see it. So let's try it with these two, one leg. I think some of the flux spat away. Come on. No, this is more of a flux problem than a heat problem, I think. Oh, it might be a heat problem. It's slowly spreading. Okay, let's get a bigger tip. That's fine. Hold on. Let's get this one. So this is a much bigger tip. Okay, let's wet that a little bit. Okay, let's try the other one. Okay. That's pretty good. Let's reflow this one real quick. Yeah, that's pretty nice. The problem I had before is that I'd always get spikes when I pulled away the soldering iron. This doesn't seem to do that at all. Okay, so as I was afraid, the terminals are basically like this now. So we're going to hold the board, and then reflow it while pushing it in. And then we can get it in correctly. So okay, last one. I need some flux. Okay, that's good enough. Solder one pin to do that fix. I know. That's what I did. Okay, let's solder the other pins, see how that goes. This is connected to a giant ground plane. Doesn't want to go at all. Okay. Too much ground plane here. No thermal relief. It's slowly going. Good enough. I do like this solder though. This is working a whole lot better than I've had before. Yeah, this is soldering almost like unleaded. So this is the ground point again, I believe. It's just, the board is just soaking away all the heat. Wait, why is my soldering iron not hot? Oh, there we go. I might still need some extra flux, but let's see if I can do it this way. There we go. Perfect. Yeah, I like this solder. I mean, those joints don't look great, but that's more me doing that. But the issue I had with unleaded solder is that it would keep wanting to stay attached to the iron when I pulled it away. And that didn't happen at all right now. Yeah, the tip is... I need to rework those. This was kind of nice. I liked it. Oh wait, and I still need to add some solder into the holes for the USB-C. I'm going to take the other tip again. You can see it glow when it warms up. Oh, it didn't do that now. Okay. So let's see if we can reflow some in here. Yeah, we're going to need flux for that. Okay. That's not going to work without flux. Yeah, all modules should be available in the worldwide store, that's for sure. Okay, I need a new syringe. Yeah, I know, but this is a stupid prototype and I should have used more thermal flux, but I probably had the area set to no thermal relief, and you know. So let's add a little bit of flux here, here, and over here. That should make it flow a lot easier. Okay, it doesn't really want to go into these holes. Could be better. Yeah, it didn't really creep up through the holes, so that didn't work that great. I'm going to add some more flux and clean it up a little bit. Shouldn't be needed that much anyway. Come on. Okay, I need my other tip. Oh, the AB version is out of stock? Okay, I'll notify them of that. Could be. We've been running in and out of a lot of stuff, so... Let's see if a bit of more thermal mass helps here. There we go. Much better. Much better. And now can we see... There we go. Now we can see on the USB-C plug that we see solder here. We actually have a little solder ball here. And we see some solder over here. And on the other side we see the same. So then we know that the whole plated through hole has been saturated with solder. So yeah. Which other connections? You mean these? No, those are fine. That'll work fine. Just gonna clean this off a little bit. Yep, that's fine. This is just a prototype testing board. Don't worry too much about it. Yes, we will send new ESP32s to Dr. Z's too, but generally we just send completed products to him, so those aren't always included. But we'll try and resupply him too. But we generally do that during the off seasons, but we'll have to see what we can do. Okay. This can be turned off now. In theory, these go in here. And there we go. Oh, sorry. And there we go. Yeah, we're continually supplying Dr. Z's right now, so it's a bit tough to keep up. I mean, the Dig Octas, we wanted to go live at the same time, and they were already in the in the plane, but it's taking a little bit for those to arrive. But once they do, he'll immediately send those out, and we'll be resupplying him with a new shipment too. So, okay. I'm going to wash my hands real quick because there's flux on them. Ow. And I don't like flux hands. One moment, please. Right. So, is this still warm? It's okay. Looking at the board, it looks pretty good. I don't think we'll need to do any repairs here. USB-C seems to be reflowed okay. And that should be on there pretty good now with the soldered legs. I guess I can show you this way. See that those holes are now filled in? So that means that the solder is all the way through the board, basically. And yeah, rest looks good. Cool. Okay, now let's keep it here a little bit longer. I'll zoom it out a little bit. So the first thing we're going to do, and my cable is gone. Damn it. Where's my USB cable? Uh-oh. I'll be right back. Okay, I found a proper USB cable. Yeah, I know. I order like giant amounts of USB cable and then don't have a USB cable. I know. But I do a testing and move around and I don't know. So, let me remove these plugs for now. Let's see if it works, because one of the things I changed in this design, the buck converter now goes to 3.3 volt instead of 5 volt, and there's no LDO on here. So it directly powers the the 3.3 volt rail. I guess we should do some multimeter stuff too. Of course, officially I should hook it up to my bench power supply and then power it that way and see what happens. But I think I'm just going to plug it into my USB and see what happens, because that's more fun. And in theory, what we should see, or hear, or well, what I should see, is we should see a connecting and disconnecting device real quick. And let me see if I can show you my device manager. Wow, that looks really crappy. How does that happen? Oh, because it's in 4K. Probably. No, that looks even crappier. Okay. I had hoped I could show you my device manager, but it's going to look crappy, but okay. Okay. This is what I've been waiting for! Right, so let's plug it in, and I can see how much power it draws. We did the LED correctly, and it's currently drawing 0.01 amp. Okay. Oh, and we get a COM port. Okay, that seems to work. Let's disconnect it. Yeah, COM port goes away. Connect it. LED works. And we have a COM port. Yeah! Uh-oh. Yeah, so at first, with the first prototype, I was like, oh no, it's connecting and disconnecting the whole time. I spent hours troubleshooting that, and then learned that's just how the ESP32C3 works. Because there's buggy firmware on there when they deliver it or something like that. So that this is happening, that's fine. That's okay. That's no problem. I'm going to measure voltage real quick. I guess I could show you guys too. There's too much stuff on my desk. It's in the way of my screens. Hold on. Let me try and show you this. There. Can I minimize this? I believe so. No, I can't minimize it. Okay, let's move it to another screen. Let's move it over here. Yeah, that works. Okay, so let's see what we have on the PTC here. 4.94, that is about correct, I'd say. And then let's see what we have on this side of the diode. Nothing. Okay. And on this side of the diode. Nothing. 4.93. Okay. And then let's see what we have at the output capacitor of the buck converter. Nothing? Why not? Okay, at the output capacitor of the buck converter we have 3.28 volt. That's a little bit below 3 volt. But I guess that's okay. And then let's check the capacitor near the ESP. 3.28. Well, that's a little bit below 3.3. So I might need to adjust those resistors a little bit. But officially we're also underdriving this LDO, or this buck regulator. Because it has a 2 volt dropout, and we're making 3.3 volt from 5 volt right now. It's kind of out of its specs, but well, as you can see, that seems to be working. I mean, 3.3 or 3.28, I'd say that's close enough. And we can measure a lot behind the dot there, and that seems to be fairly stable. Although, I'll have to check it with my oscilloscope later. So that seems to be working so far. Now let's see if we can program it with some software. Oh man, it's disconnecting the whole time. Hold on. Yeah, I'm working on an on-screen display for my oscilloscope, but we're not there yet. I'll do oscilloscope tests later for myself. Let's see if I can share this screen. Right, so this is my test Home Assistant installation. And I have a CC1 here. And there is a config in there that I've used before. Let's see if I just revealed all my passwords. No, just a testing one. Okay. Anyway, there's a configuration in here. Let's build that and flash it. Oh, that's really lagged. Okay. Install. And I want to manually download it because I need to flash it using the online tool. So let's build that real quick. To do every stream. Yeah, I have a testing network too, so even if I do expose it, that's fine. I chose this buck converter because it can handle 80 volt in. And we're going to power it with 60 volt in a minute, so yeah. Cool, that seems to have compiled fine. Let's download that, and then I need to do the stupid thing again. Install, manual, and then open ESP Home Web. Okay, and now I need to hold down one of the buttons. I don't remember which one. So I'm just going to try one, and then plug it in. Nope, failed. No, it's still disconnecting, so it's the other one. Because that forces it in boot mode. Okay, now it's staying online. So now I should be able to say connect. USB JTAG serial interface. And install. Choose file, download, CC factory, yeah. Install, yeah, let's go. Erasing! Oh, noise! That means the connection from USB to the ESP32C3 is okay, because otherwise it couldn't do erasing. Installing! Noise! Configuration installed. Okay. Let me check my router. Log. Okay, there doesn't seem to be an IP request, but let me disconnect it real quick. Let me go away. Yeah. Let me disconnect that. It's not asking for an IP. I wonder why. Let's check the voltage real quick again. Yeah, it's still at 3.28. It should be fine. Let me check my code real quick. Oh, right. It's not asking for an IP because it got a static one. I think. Oh, let me check. What is the status page again? Does that work even? Okay, yeah, let me see if I can ping it. Because this ESP32C3 stuff, it's just not fully hashed out yet. I can ping it. Okay, so if I can ping it, I should be able to add it into Home Assistant. Or actually, it should already be there. So let me give you visibles again. Visibles. CC1. Yeah, it's online. Nice. 43 seconds. This is the 3-hour live stream, yes. Well, 2 hours and 59 minutes, so, huh? But good, this is one of the things I changed. I changed by removing the LDO. Because, you know, that's 1 part less. So now it's getting directly 3.3 volt. Even with the 5 volt in through a diode, that seems to work just fine. Cool. Okay, so the next test is disconnecting that. And giving it 60 volts. Or let's give it 55 volts or something like that, but yeah. Oh, I need to turn it around, because otherwise I can't make that work. So let me find a screwdriver. No. Yeah. Now, these are plus and minus, because you can loop them. That's the idea. But with the cables I have currently connected, I'm just going to do it like that. And you're not supposed to do that. But if you screw that down tight enough, I don't think it'll contact anything else. And this is just looped. So on the other side I can do this, and that should be fine. Yeah, I use orange LEDs on all my stuff. Or most of my stuff. Okay, so now this is connected to ground. This is connected to positive. Can I... Oh no, I need my cable here to go to my bench power supply. Hold on. I need to get this cable in there. How is it in there? It's never the way you think it is. What? There we go. Okay. So this is my Raiden 6012. So it goes up to 60 volts. For now, let's set it to 1 amp. 24 volt. Right? Positive, negative, nobody's screaming at me. Okay. So this is the first time this part of the circuit will get power, because the USB only does this part of the circuit. Yeah, I guess we should just hit it, right? On. Oh yeah, right. If it explodes, hang above it with your head. That's very smart. Okay, that still seems to work. It's drawing 0.0 watts. It's drawing almost nothing, but it's at 24 volts. So, I mean, that is at all possible. This is now... Oh, well, okay. Oh, you can see. Okay, this is 3.28 volts. So that's still a bit low, so I might need to change the resistor there to a bit higher value. But 3.28 should be fine for the ESP32C3, right? So input voltage is now 24 volt. Okay, let's, I don't know, we need much higher than that. So let's go to 50 volt. So we're now at 50 volt in. Okay. What is the ESP getting? .28, 3.29. Okay. And it is actually online. Okay. Okay. That all works. No smoke, sad face. Well, we had smoke during the reflowing. Okay. If that all works. Huh. Let's see if something's getting hot or not. No, it can't get hot. We have a power draw of 0.00. So nothing is getting hot, because then it would draw more power. Okay, I turned it off. Let's get a light. This is a light, right? No, actually, I need to check the firmware here. No, damn it. Okay, hold on. I'm excited. It's working. So, let me check the firmware on my own real quick. Okay, yeah, it's set to 450,000 hertz. Let's not do that. Let's set it to 1,000 hertz. Okay, save. Let's power it on. And in theory, I should be able to OTA it. Okay, let's install wirelessly. Let's see if it can do that. Yeah, it can do that. Nice. It's uploading wirelessly. So we should also be able to see the logs then. Okay, yeah, Home Assistant connected to it. So now this should work. Yeah, triggered on, triggered off. Okay. It's at 50 volts and 0.1 amps. I'm going to... we could blow up this light. I'll remove the screen. So, let me... okay. I'm going to plug in the light now. And it'll either blow up or not. No, wait, I could measure the output voltage, couldn't I? Okay. I'm going to do the smart thing. The smart thing would have been to label these terminals, which I didn't do. Let's see what voltage is on here. Other way around, probably then. Okay, 3.7. No, that's just the capacitor filling. Okay, so let me turn on the CC output. And that'll probably produce some weird results. Nothing? Okay, it's outputting 50 volt. That is correct, because there's no power draw, and then it'll raise the voltage as high as it can do. In theory, that is working. In practice, if I plug in this light, it could blow up. Oh, right. I have the labels over here. Okay. I'm going to plug it in. Okay. We have light. Oh, we have light. Can I control it from Home Assistant? More light? Oh. Oh, but I can already see an issue. Okay, so this is full power. But if I dim it down, you can see PWM waves. Damn it. So this is the second prototype, which works, which doesn't work. Or, you know. Let me see here. Oh, wrong way around. Yeah, it's getting 28.6 to 7 volts. So the auto regulation is working. It's getting the milliamps that it's supposed to be getting. And then it assumes whatever voltage it needs. And the regulation is working because I can dim it up and down, so I can turn it off. And I can turn it on again. And I can dim it down. Yeah, I can dim it down until you can always see the cob itself. Or I can give it full power. Cool. So that part is all working. So the circuit looks to be correct. But if you look closely, you can see the PWM waveforms there. Let me turn the office lights off. Oh, you can hear it. Right, you can see the PWM, and it's currently PWMing at 1000 hertz. Maybe 1000 hertz is too low. Okay, maybe let's go to 10,000 hertz. OTA wirelessly, let's go. Yeah, I'm in the dark here. Okay, so now it's probably online, but the dimming value is too low. Oh, it's still unavailable. Oh, there we go. Okay. Yeah, we're not seeing a PWM value right now. I can raise it up high. I do love these lights. They're high CRI. We have all through our house. So we're currently at 10,000 hertz. It might be there. I don't know. Let's measure the output again. Yeah, voltage is stable, but yeah, no, but the more PWM frequency you put in there, the smaller the range and the smoothness of the dimming. So you want the PWM, the ESP32C3 is doing, to be as low as possible versus having a stable output, basically. But the question is it working, as in, is the output current stable, or is the PWM waveform still coming through the output, basically? Because that's what you kind of want to prevent, is that the PWM wave we're sending in to dim the chip comes out of the light. The PWM should be buffered in this inductor here and smoothed out so that it's a constant current going to the actual light instead of PWM, because we don't want PWM. We want PWM as an input to lower the output, but lower the output current in a constant form instead of going up and down. But then you need to switch the inductor fast enough, so that's going to take some figuring it out in the end. I mean, yeah. You can hear the coil whining right now. I don't hear it right now. I can't hear it right now. Extra output capacitance can help up to a certain point, but in the end, it's a combination of the frequency the chip is generating and your inductor, and you basically need to saturate or not saturate your inductor in regards to the output. No humming now. Okay, yeah. Yeah, and it's at 10 kilohertz right now. Right? But my the band I have available for dimming is pretty low now. Yeah, because this is already off. Yeah, so this is now the lowest value, 35%. That might need some adjusting too. That's still pretty smooth. So we're converting any voltage to a given current. What does the ESP32 do? The ESP32 does that I can communicate wirelessly with Home Assistant, and I can dim up and down the light, basically. Oh, Philip has to go. I'll catch the secret tomorrow. I don't know if there is a secret. This whole board was a secret, so... Yeah, you can use gamma correction, that's true. I don't actually know if I already have some gamma correction on there. I have it turned off in ESP Home. I had it on there, but it's off currently. But hey, as a first result, this isn't bad. I mean, my buck converter to 3.3 volt for the ESP32 is working. The ESP32 is online. We were able to program the ESP32. And our light's working. We have output. The dimming works. We can connect the Home Assistant. So, hey, all in all, it's not that bad at all. There might be some fine tuning needed, sure. And I hope I can find the frequency. But I have to hook up my oscilloscope and do a lot of testing where I get an actual constant current without the PWM left in the waveform. But yeah. The lowest voltage this will work at. Well, that's not the idea. The highest voltage this will work at is 60 volt. And then the light will use whatever voltage it needs. So we're currently inputting 50 volt at a max of 1 amp. And the light is using 32.14 volt. Because that's what it needs. So we're inputting 50 volt. And the light will use whatever it needs. Yeah, there will be some drop, but we saw it output 49 volts, so... But the lowest voltage is 5 volt, I'd say. Because that's already kind of below what this buck converter officially supports. We saw that it works, but yeah. But, you know, with buck converters and things like that, and these outputs, I really need to watch my oscilloscope for a few hours and figure out if it's working correctly or not. There's no way to do that with a multimeter, even if you have a few $100 multimeter with that many numbers behind the dot. You need to hook up an oscilloscope and do testing. I believe the ESP can, but I'm not sure it's implemented in ESP Home, Christian. Then again, for this board, it doesn't really matter too much because there's only one output channel, so. I mean, yeah, it looks great. But if there's PWM, yeah, I mean, then I could just hooked it up to a normal constant voltage thing. Still, this already looks better than I've seen before. So, I mean, let's see the lowest I can go. And then it turns off. Okay. Yeah, it needs 31% to turn on. Okay. Not too bad. Yeah, it's a new territory for me too. I've been experimenting with a little bit for a while, but I'm already happy that, you know, most of the stuff on the board works. Now let's see if it works correctly. What is the voltage at 100% output? Sure, I can measure that. So it's set to 100%, but it's not actually at 100%. And I'll explain that. 34.6, and I can leave this on here and adjust it. So I can turn it down, and you can see that it draws less voltage because it just doesn't need that much voltage at that level. And at some point it'll drop below the voltage that it can display in output, but the voltage is still there. So the light is still getting 18, 17, whatever volts. It's just not displaying any light anymore. There we go. Arun, you can actually just look on my website. I think I have ESP Home examples for all of it, and just piece together what you need. I flashed it with ESP Home, Rob. Yeah, I know that the dispersed or distributed PWM, where it basically staggers the PWM outputs. I believe the ESP can do that, but I'm not sure it's implemented in ESP Home. Yeah, I might need some tuning for that. I know I gave this light 250 milliamp, but I believe it's actually 350 or 375, something like that. So I'm underdriving it anyway because it's a 13 watt LED, yeah, basically it needs more power, so that might also be the reason why it's not doing as much as it should. Yeah, so if we do 13 watt divided by 35, that gives us 371, and we're only giving it 250 millivolt instead of around 375 to 400. So that might also be the reason why this light is not doing so much in the lower regions, because it just needs more power. Which, you know, is fine. Could you measure the milliamp output? Yeah, I can, but it's difficult right now. Because I'd have to put something in line, basically. And I don't want to do that, because I'm a bit tired after, you know, 3.5 hours of streaming. So, so we're also going to start rounding off. I'll put some nice... oh no, it's bright. Nice light on my face here. It's not that it's dim, because if I put it on full power, I mean, you can see it lights up pretty decently, but it's not driving it at full output. But that, you know, I knew that. That's fine. Let me dim that down a little bit. There we go. So yeah, I'm actually pretty happy because I changed a lot of the design versus the version 1 here. And right now it's just, I need to start testing with an oscilloscope. And maybe I need a 200 microhenry inductor instead of a 100 microhenry inductor on the constant current version. Maybe that'll, you know, allow it to keep up instead of having to need a higher PWM frequency. Maybe I can go through a 300 microhenry and then lower the PWM frequency because it can keep the output saturated, for instance. And there's lots of testing to do there. But yeah, that's part of the hardware design stuff. I'm already happy that basically the basic stuff, so USB-C input, programming over USB, the buck converter for the for the ESP32 works from 5 volt all the way up until 50 volt. That's a huge range for it to work. There's no LDO there, so it's making 3.3 or 3.28, might need to fix that too, stably from all those voltages. So my buck converter design there seems to be working pretty good. And it's also directly connected to a buck converter instead of having an old LDO in there, which kind of buffers the signal normally. But again, that needs to be scoped to be sure that it's actually working stably enough, because there's a certain millivolt you're allowed to fluctuate, basically peak to peak, and you can't do that with a multimeter. So lots of scoping to do in my future. But yeah, the basic stuff works. We programmed it. It's online. It's stable so far. And I'm quite happy with that. You need to do some EMI tests as well. Yeah, that's harder to do at home. But yeah. And as said, I have no clue what I'm going to do with this project yet. This could be just a fun exercise for myself. Or I might release it as a DIY project, although it's very tiny SMD components and things like that. So probably only a handful of people in the world are going to build that. Or I might make a pre-assembled version in a nice little case for that and sell it. I don't know. Yeah, Rob. That's just a tweak to those resistors. That's not a problem. And 3.28, I believe it's, it can run it down to 2.8 or something like that. But that's easy. Oh, you run into problems with EMI and Wi-Fi reception. Need to reorder the board sometimes. Oh, okay. So far this has been fine. Yeah, Wi-Fi reception is strong. We're getting minus 55 dBm. It's decent. So yeah, I'll do more testing. But so far for today, I'm happy. So I have no idea who's actually still here because I couldn't see my YouTube stats. There we go. There is 54 people still here. Okay, cool. Well, you made it to the end. This is the end. I thank you all for watching. Give it a like if you haven't done so yet. That's always good. And oh, Phil. We're just heading out. Sorry, man. Well, you have 3.5 hours to watch back if you want to. So, thanks all for being here, and I'll catch you guys in the next live stream. Video on the Discord, in the comments. We'll see. Bye-bye. Yeah, and the secret, Avenge CJ's right. The secret is there's no secret. This was the whole secret.